So we are talking about derivatives of natural logs, and I have two new rules that we'll learn and practice and that you will have to memorize as we work through this next chapter. The first rule is the derivative of natural log is 1 over x. This little part after is a condition, x greater than 0. When you take the natural log, you can only take the natural log of positive numbers, and so that little piece after that condition is just saying that if you're going to do this rule, it would be only for x's that are greater than 0. The second part is if you have an expression after your natural log that is different than just a plain x. So you would represent some kind of function like x squared or 2x plus 5 or something like that. If you have a natural log of something other than x, then you'll have to do a separate step, which is first the 1 over u, which you saw here, and then multiply by the derivative of u. So I'll go through a few examples. This first one is natural log of 2x. So what we'll do for the derivative, which we'll call y prime, would be first 1 over the thing being natural logged. So 1 over 2x. And then because it's not a plain x, we'll follow this rule, 1 over the thing, so 1 over 2x, times the derivative of the thing, which the derivative of 2x is 2. So this would be your whole answer. We'll simplify it by canceling out our 2's. So the answer to this one would just be 1 over x. Next one, natural log of absolute value of x. The absolute value of x just keeps it positive. It's not going to affect our derivative. So we'll follow we'll follow this 1 over the thing times the derivative of the thing. So 1 over cosine of x times the derivative of cosine of x, which is negative sine of x. I'm going to slide those things together just to simplify. And this would be my answer. This would be just a fine answer. An even better answer would be to recognize that sine of x over cosine of x is tangent of x. So this would be even better. So either one. The last example that I have is just a little bit more complicated. It's natural log of a product, x times square root of x plus 1. And we have a composite function here, x plus 1 is being square rooted. So there's a lot more complexity to this one. And if we follow this rule, we'd have to do 1 over this whole thing times the derivative of this whole thing, which would be the product rule, and then also a chain rule when we got to this part of the product rule. So it's doable. It's very tedious and very algebra heavy. So I'm going to recommend that before you do a problem like this, you use your properties of logarithms, which we practiced earlier in this section, to rewrite the function first. So I'm going to say x times square root of x plus 1. I'm going to separate into 2 logs separated by a plus. And also I'm going to bring this half down in front. Now I have a pretty simple, like the most basic natural log function here, and then a pretty simple one here too. So now when I go ahead and apply my derivative rule, it's gonna be very straightforward. So first this part, ln of x, the derivative would be 1 over x. That's it. Second, this part, when I have a coefficient, the coefficient just sits out in front. So natural log of x plus 1 would be 1 over x plus 1 times the derivative of x plus 1, which is 1. When I simplify all of this, it'll be 1 over x, that's that part. And then this part, I don't need the times 1. 1 times 1 is 1, so I just have 2 times x plus 1 in the denominator of that second fraction.